Hi, my name's Steve Motter, and I'm an ecologist, and I study spatial population dynamics, particularly of alpine butterflies.
And what are your research interests?
I'm interested in the effects of climate change, and kind of through many different angles. And I'm also interested in understanding what happens when a population within a network of population goes extinct. What happens to the survivorship or the ability of the surrounding populations to withstand that local population extinction.
And so you've joined the early adopter program for Scholar at UC, the institutional repository. How does Scholar help you with your research?
Well, in particular, Scholar is very important for helping me database my research and make these data sets accessible. One of the things that our funding agencies often ask us to do is to make the products and the basic parts of our research accessible to other people and other researchers. And I've found in the past, I've tried to do this with different institutions, and unfortunately they lost their funding. And so my data set is out there, but it's no longer being curated, and the software isn't being updated, and so it's there, but it's hard to find. And so putting these data sets in as many places as possible increases access, but it also is going to increase the longevity of the data set in case something like this happens. It sort of spreads the risk. So I hope UC never goes away, but we never know.
So actually, the point about spreading the risk and future research, can you speak a little bit about how in the future this would be helpful?
Well, what I've collected is a long-term population data set, and there aren't very many of these, particularly with multiple populations that are kind of interconnected, these spatial population networks. And so we have data that goes back to 1995 to the present. And making these data available to other researchers in the future who may have better techniques and better ways to analyze these data than we currently have would be a kind of a boon. They would have something where they could take their new model and say, oh, okay, here's a data set that fits this perfectly, and we can apply this model to these data to answer questions that maybe we haven't even thought of now. So I think keeping these data and preserving them is very, very important.
And I remember from our first session that you have collaborators who are not here at UC, right?
Correct.
So does this help you as well in working with your collaborators?
Yes, to some degree, in that they can log in and see the data set. We don't use the kind of real-time facilities of it because our data set isn't huge and it's not being kind of updated daily or things like that like some other people. But yeah, it does increase access that I don't have to email them a file. They could go in and check out what I've changed and go in and look at that. But I have colleagues in Canada and Finland and kind of across the world.
And you mentioned funding agencies. Do you have requirements from your funding agencies that specify a certain amount of time that you need to have the data available?
Yeah, there's not a set time frame for the National Science Foundation. They give you enough time that you can publish that data, but a lot of times when people publish data, they also want to make it available at that point. So given the takes maybe 2 or 3 years to collect the data, analyze the data, get it out, and usually at that time people now are wanting to kind of put the data out once the publication comes out.
How about for your teaching needs?
We actually use these data in introductory ecology and introductory environmental science. We haven't linked up the classroom with the program yet so that they could pull it down, but that would be really simple, and they could just access the data rather than us kind of giving them the file. Mm-hmm. But I think it can and probably will become more seamless like that they can just grab it and say the questions that we have them ask are to what degree is density dependent regulation and density independent regulation important for these for these butterflies, and they go through and kind of look at those effects.
So you're also modeling what future scientific behavior would be like to access data in a repository, right? So they're learning that research of data process.
Yeah, how to go about getting data that they may want for some completely other purpose. You know, they can go in and find it, and I think that would be an important tool, learning that rather than us kind of handing them the data.
So you mentioned that the data sets you have in the repository that's no longer being supported, not being well curated, and thinking about these young scientists accessing that data, what components need to be there for them to find it? And how does Scholar help you with those components?
Well, Scholar adds sort of keywords and sort of accessibility, whereas you would have to know, one, that this repository existed in that case, and then you would have to go to that repository and search all of its all of its files, basically all of its data sets, to see what kind of data sets are there. And mine didn't fit their model very well, in that they were a population database, so they were kind of interested in single populations over time, whereas I have 21 populations that I'm looking at over time that are all interrelated. And they didn't really have a way to say, okay, well, let's make a join for all these, or let's say that there's a spatial component to all these. It was just, here are 21 different populations. So, and that's where the curation is important, because no two data sets are ever alike, and they're never going to fit kind of every model that we try and fit them into. So having that kind of adaptability and ability to tailor things to specific needs is important. And so, that with no one curating it there, no one may ever notice that the 21 populations that I submitted to that database are actually all in the same network. So
by the fact that we as Scholar gives you the ability to be the curator, so you can make sure that the information that is needed is there, right?
Yeah.
Because you are the source of the data as well as the information about the data.
The metadata. So so it's all there, and it's nice, and I can go in and update it. In my case, for this data set yearly, when I get another population estimate, I can put it in, and it's there.
And remind me, your research takes place where?
Oh, it's in the Canadian Rocky Mountains. It's a place called Kananaskis Country, and the specific place I work is Jumping Pound Ridge, which is a wonderful place.
Are you going again this year?
Yeah,
every year you go?
I've been going every year since 1998.
Wow.
So.
And how many people go with you?
I usually
what are their functions when they go with you?
I usually take 3 undergrads with me. Usually they're kind of employed to help do the mark recapture on the butterflies, which we do for the population estimates and measuring dispersal among the 21 populations. But usually they also have an independent research project. So what we're working on this year is the oviposition sites for females to see if they oviposit within the meadows kind of randomly, or if they actually select areas that may have more or less snow cover to, if there's no snow cover in the winter and the temperature gets to minus 28 Celsius, we think the eggs will freeze and die. And this is where the climate variability kind of comes into it, because some years you have lots of snow cover, other years it may snow but then melt off and go away. If you have it kind of melt away, the snow doesn't act as insulation, and so the temperature on the ground where the eggs are can get to the lethal point, the freezing point of the egg. And so I'm kind of wondering whether females haven't evolved to be able to maybe select shadier places or places that would retain snow throughout the winter a little bit longer, so they may select those areas to oviposit in. But there's kind of a balance too, because if they're there too long, it may take a long time. If you have a particularly snowy winter, it may take too long for the snow to melt, for the larvae to hatch and actually be able to kind of make it through and develop over the summer. So those are the kind of smaller projects that students can do kind of in 1 year or 2 years. And so I've had many students do research projects with this.
Would you consider contributing their research to Scholar as well?
Yeah.
Like that's part of the
yeah, I mean, part of the data that they collect. There are also other data sets that we have, temperature data and climatic data, which I use to understand what's happening to the butterflies, but temperature and rainfall data affect all kinds of things. So that type of data is valuable kind of across many different fields. So.
Are there any other things about Scholar that you have had, like being a part of the early adopter program?
It's kind of fun to see what the other people are doing too, and to see, it's kind of like a little community where you can say, oh look, someone else posted some more data and their data set and what it is, kind of, you often get a feel for, what the results that these people create, but sometimes you don't see, this is the data that produced those results, and sometimes it's, massive amounts of data, which is really kind of scary in some ways.
So it helps to bring out the research process.
Yeah,
which is also helpful for students to see the entire research process.
Yeah, going in, I hadn't thought about that, but yeah, that would actually be an interesting thing to see. Okay, well, here's the type of data, here's where it came from, and it gets you kind of one step closer to the science. Mm-hmm. So. Yeah.
Do you think it helps improve the level of science or what people are doing, or it helps bring new analysis techniques if you see the data and then what gets published as it's been analyzed?
Yeah, potentially. I mean, that actually is a neat point, because I teach a data analysis course, and I always just pull data sets that I have to illustrate certain things, and sometimes they're kind of contrived. Like I'll just make up data and say, nitrogen levels do this to plants and watering does this, and here we'll analyze it this way. But searching through those and looking for data that would actually be kind of more interesting and real data would probably be fun for a class like that, to kind of look at different things. But yeah, I actually hadn't thought of doing it through Scholar.
Well, hopefully we'll have lots more data for you to be able to have all the examples that you need for your class. That would be really fun. I'd love to come to that class, actually. So, that's pretty much the script that I have. If there's anything else that you can think of or would like to say, or
no, it's been fun being an early adopter. So.
Well, we really appreciate it, because when we get the feedback, it really helps us to improve the functionality of Scholar. Mm-hmm. And there have been quite a few changes, and you can actually monitor those changes on the website. You can see when they've done updates and things, and so you'll see it evolve as we go through. Yeah,
I actually haven't gone through since it changed over. I haven't gone in and looked to see what the new format is. But
well, we'll be coming around soon, like I said, and be able to get that information from you. So.
Okay, great.
Well, thank you.
You're welcome.